Today, we started Investigation 1 in prime time, building on factors and multiples. We did Lesson 1-1, playing the factor game, finding proper factors. A proper factor or factors are all of the whole number factors of a number less than the number itself. For example, just like the one in your book, they gave us the number 12. Its factors are 1, 2, 3, 4, 6, and 12. But if we're looking for proper factors, we need 1, 2, 3, 4, and 6. Because a proper factor is any whole number factor less than the number itself. So we can't count the 12. So it is one of the numbers or two of the numbers you multiply together to get an answer. Your first problem for homework is Ben claims that 12 is a factor of 24. So we have 12 and 24. Ben wants to know if 12 is a factor and how you can check it. Well, you can count by 12s, multiply, or even divide. So I'm looking for you to show me how you know 12 is a factor of 24, or if it's not. So if I do 24 divided by 12, I have to think to myself, okay, 12, that's 12 times 1. Now if I times it by 2, I get 2 times 2 is 4, 2 times 1 is 2. I get 24, so it goes into it twice. So is 12 a factor of 24? Yes. Why? Because 24 can be divided by 12 evenly. There's no remainder. B says, let me erase. How would you test whether 7 is a factor of 291? Again, you can skip count by 7s, but that would take you a really long time to get to 291. So we have 7 and we have 291. Again, let's divide. Now, using any method you choose, 7 can't go into 2, but 7 can go into 29, and it goes in 4 times. Let me erase this and move it down. Four times 7 is 28. I subtract 9 minus 8 is 1, 2 minus 2 is 0, and I bring the 1 down. How many times does 7 go into 11? Only 1 time. And then we would have 1 times 7 is 7. 11 minus 7 is 4. So there would be a remainder. Is 7 a factor of 291? No. So on your paper, I need to see no because. And I will accept your work as an answer. If you want to add some no words, no, because 7 does not go into 291 evenly. There is a remainder. Your next one is looking at factor pairs. If I'm looking at pairs, I'm looking at two numbers, like a pair of shoes, you have a pair of feet, you have a pair of ears, you have a pair of eyes. It's all 2. So, what factor is paired with 6 to give 24? So we're thinking to ourselves, 6 times what equals 24? You can list your multiples if you need to off to the side. You can say them in your head. Use a multiplication table on your homework. I don't care. As long as you know that what we're looking for is what number I have to multiply 6 by, that's what I want you to know. So 6 times 4 equals 24. 2b, what factor is paired with 5 to give 45? So 5 times what equals 45? Counting by fives, 5, 10, 15, 20, 25, 30, 35, 40, 45, we get to 9. 2C. What factor is paired with 3 to get 24? Count by threes, you're going to get 8. 3 times 8 equals 24. 2D. What factor is paired with 6 to give 56? So 6 times what equals 56? And it's 9. Now let's look at number 3. Which of the numbers 19, 21, 23, and 25 has the most factors? So let's look. 9. The only factors I know of 9 are not 1 and 19. I can't think of anything that I multiply together to get 19. Then we have 21. Again, you always know one factor pair, 1 and 21. My next factor pair is going to be 3 and 7. So this has 4 factors. Then you have 23. Again, 23 only has 1 and 23. I can't think of anything else that's a whole number that you can multiply to get it. Then you have 25. 1 and 25. And then it's just a 5. I'm not going to list 5 twice. 5 times 5 is 25. So which number has the most factors? 21 with 4 different whole numbers. B wants you to find a number greater than 25 that has more factors than the numbers in part A. Okay, let's think. We might go with an easy one. Maybe you go with 100. 100 is 1 and 100. 2 and 50. 4 and 25. 5 and 20. And I think that's it for factors of 100. So is a 100 greater than 25? Absolutely. I shouldn't see 100 on your paper. I want to see something other than 100 on your homework paper so I can see that you understand how to find factors. C says, find a number smaller than 19 that has more factors than the number in part A. So again, I'm thinking, okay, what is something bigger, smaller than 19, but going to have more than 4 factors? So you might have 18. 18 is 1 and 18, 2 and 9, 3 and 6. So right there you have 1, 2, 3, 4, 5, 6 factors for 18. Try 15, try 16, try 10. See which number, smaller than 19, so I'm talking 1 to 18, has more factors than 4. A, the calculator screen below shows the results of dividing 84 by 14. What does the answer tell you about 14 and 84? So your page, because I couldn't get a good picture, is 84 divided by 14. And then you have the answer 6. So earlier, we figured out that 12 was a factor of 24 because when we divided, it gave us an even whole number. So we can say that 14 is a factor of 84. How do we know? we know this because we were given an answer that was evenly. So then B says the calculator screen shows below the results of dividing 84. So you have 84 divided by 15. And you get 5 6/10. What does this answer tell you about 15 and 84? 15 did not go into 84 correctly, which means that 15 can't be a factor of 84. We also talked that sometimes you can use the word divisor as another word for factor. So 5A says, is 6 a divisor of 3? And so what it's asking you is, can 18 be divided by 6? The answer is yes. Because 18 divided by 6 equals 3. So I want to see yes because and show me. Draw me a picture. Now it says, is 18 a divisor of 6? Why? So now you're reversing it. It wants to know can you divide 6 by 18? You can, but you're going to get a decimal point. So no. And show me why. You can't split 6 into 18 evenly unless you have a fraction or a decimal. The next one says, which of these numbers are a divisor of 64? So you have, I want to see 64 divided by 2, 64 divided by 6, 64 divided by 8, 64 divided by 12, and then 64 divided by 16. So 2 goes into 4 2 times, 2 goes into 6 1 time. So, or 3 times, I'm sorry. 3 times. So look, we have 64 divided by 2 equals 32. We already then know our answer to 64. Oh, I lied. We don't know our answer yet. So then we have 64 divided by 6. If I had more room, I would work out the problem. But if I do, I see that, so 6 goes into 6 once, but it can't go into 4. So we're going to end up getting a decimal. 10 remainder something. 10 remainder, 6 goes into, so this is a no. Then you have 64 divided by 8. My favorite rhyme. 8 and 8 went on the floor and came back up as 64. So here's a factor. Then you have 64 divided by 12. Well, we know 12 times 5 is 60. So this can't be correct because we couldn't have another, no. We couldn't have another 12 from that 64 if we already made 60 with 5 12s. And last but not least, we have 64 divided by 16, and that equals 4. So, which of these numbers are a divisor of 64? 2, because it goes in 2 goes in evenly 32 times. 8, because 64 can be divided into 8 times. And 16, because 64 can be divided by 16 4 times. Sam knows that 3 is a factor of 24. So this means 3 times something equals 24. Another way to write this is 3x times n equals 24. For each of the statement, find the value of n that makes the statement true. So we want to know what n is. So for 7a, n is equal to 8. Now, we really haven't practiced this, but one way you're going to learn how to do it eventually is if I divide this side by 3, I'm going to be left with the n and you get 8. But for right now, if you just list your multiples, I'll be happy with that. Or if you want to try it the quick way I just showed you. So then you have 5 times n equals 60. So what does n have to be? 5 times what equals 60? N must be 12. Then you have C is 12 times n equals 144. So what does that equal? List off your multiples of 12. Look at a number chart. Divide. 12 goes into 14 once. I have 2 left over, so then I bring the 4 down. So if I'm dividing, so I have 1, a 12, I have 2, and then 12 goes into 24 twice. So n equals 12 for C. D. Ooh, here's a tricky one. 160 equals 8 times n. Don't let this trip you up. It wants to know what times 8 equals 160. Again, divide. 160 divided by 8. 8 can't go into 1, but it can go into 16 twice. 2 times 8 is 16. I get a 0 and a 0. So my answer is n equals 20. Don't let a reverse problem scare you. Now, here's one. You have 2 times 3 times n equals 54. Well, we know our order of operations, so let's start here. What's 2 times 3? It's 6 equals times n equals 54. So if we do 54 divided by 6, we get 9. So now we have n times n equals 9. I could do 1 and 9, but I bet if I did 2 times 3 times 9 times 1, 2 times 3 times 9 times 1, you don't get 54. So what's another factor of 9? 3. So if I do 3 times 3 times 3 times 2, I get 54. 2 times 3 times 3 times 3. I get 54. So our n's have to be 3, because 3 times 3 equals 9. Or you could do 9 and 1. Either way. Let me see your work.